So let's take a look here in 4.1 at what exactly a probability distribution for a discrete random variable actually looks like. Now the nice part here is that when I look at this box, I'll see that I have this little table over on the side. And we've made tables like this in previous sections. We made like frequency and relative frequency tables that have this basic shape. And what's interesting is that this is realistically just the same thing. So a probability distribution for a discrete random variable x is really just going to be a list of all the distinct numerical values that x could possibly take on. So if I was thinking about, like in the previous video, the number of students that earn an A in a stats class, I would list out maybe 0, 1, 2, 3, all the way down until the number 15. Those would be my options. And then on the other side of the table, what I'm going to be listing down is their associated probabilities. So what is the probability that 1 student will end up with an A, or 0 students, or 10 students? And I'll list those in the table, so it's nice and organized. I can see the possible outcome and its associated probability on the other side. Of course, I still have to have the basic rules of probability still in play. Every probability that I have should be a number from 0 to 1. And all of my probabilities better add up to 100%. So these are the basics of our probability distributions for discrete random variables. Now we're going to practice this idea down here in example number 2. But before we go ahead and do that, I'd like you to go ahead and go to the exam materials folder and take a look at the formula sheet associated with our current exam. So what I have listed here is the formula sheet that we're going to use this semester, specifically related to content around exam 2. Now, first off, it's going to be really good to have this formula sheet with you on every single video that you watch for this class in this unit. Have it out for every worksheet problem that you're working on, for every homework problem during the exams. This worksheet is, or this formula sheet is going to help kind of organize all of the different ideas that we're discussing and put it in a format that's kind of easy to grab, as well as easy to understand kind of the process of how we move through each question. Now, what we're first going to go ahead and see here is that in this formula sheet, we have a bunch of different columns, and each of these columns is going to kind of correspond to a different section or set of sections. Over here, we're going to have section 4.1, that's our current section, in this first column. We're going to have section 4.2 in our next column, and in our third column, we're going to have actually all of chapter 5 represented. Then we're going to have section 6.1 and section 6.2. And so it might be good if you have a copy of this to kind of label that on your own copy so you can kind of associate each section with each one of these different columns. Now, the reason that I've separated out between red and blue here is that we'll see that these blue columns are associated with our discrete distributions, whereas our red columns are going to be dealing with continuous distributions. So that's also important to note. But the real awesome thing about this formula sheet is that it acts as a flow chart for how you and I can go through each individual question. And that's what's positioned here over on this very left side. We're going to see here that every time that we complete a probability style question within this second unit, we're going to be following exactly this flow chart every single time. We're going to start here at the top by defining always a random variable. What is the problem talking about? Is it talking about the number of miles that a car is driven? Is it talking about how many students are in a classroom? What is it that we're measuring or counting? Then we're going to have to go ahead and try to identify what special kind of distribution am I potentially working with. And so we'll go ahead here and we'll be able to kind of see how we can actually use our first column here, as well as this flow chart pattern, to actually go ahead and answer question number 2. Let's take a look at what example number 2 says. All right, Kyle likes to watch TV. True story. During the rest of this week, Kyle will watch up to 3 episodes. It's very true. I'm a busy guy, so I don't have time to just, be binge watching all sorts of stuff. So there's a 30% chance that I'll actually get to watch 3 episodes of something. There's a 40% chance that I'll watch 2 episodes, and a 17% chance that I'll only watch 1 episode. So, I can watch up to a maximum of 3, but then these are some percentages to let you know, what are the odds that I actually end up watching this many? Well, if I take a look at part A, I'm being asked here to create a valid probability distribution where, here's the first step of every problem. Identify what the random variable is, where X represents the number of episodes watched by Kyle. So what I need to be able to do in my head right now is that every time I see X, I think the number of episodes watched by Kyle. That's what it stands for. So I'm going to go ahead and over here, I'm going to make a nice little table. I'm going to have my different possible X's, number of episodes watched by Kyle, and their associated probabilities. So let's see, what would be all the different possible things that could happen? Well, I mean, if I'm just kind of following what I have up above, it says that it's totally possible that I could watch 3 episodes. That's one possible value that X could take on. It also says, though, I could watch 2 or maybe even 1. But if I write down all the associated probabilities, I'll notice that I have a 40% chance. I have a 17% chance. Oh, wait, I have that in the wrong order. 40% was with 2 episodes, right? It says there's a 30% chance that I will watch 3 episodes, a 40% chance that I watch 2, and a 17% chance that I watch 1. Notice right now, there's a problem. Look at all my percentages. Do they add up to 100%? No, they don't, which means there's no way that this can be valid yet. I'm actually missing a possible option here for my X. If I can watch up to 3 episodes, how many episodes could I still possibly watch that meets that description? Yeah, I could actually watch 0 episodes. That's possible, right? Maybe I don't get to watch anything. And if I know that all of these percentages have to add up to be 100%, then I should be able to figure out what percentage I'm missing. If you crunch it out, I think that's actually going to be 13%. Now, just in case some of you are wondering, hey Kyle, wait a minute, what about, if you watched 1.5 episodes? Well, there's an issue with that. First off, I would never actually watch 1.5 episodes. I'm a very committed individual. If I'm sitting down to watch something, I'm watching the whole thing. But here, I'm actually talking about the number of whole episodes that I'm going to watch. So I'm not dealing with any partial amounts. It's either completely 3, completely 2, 1, or 0. That's it. But this is part A, all finished up. So in part B, we're now going to be asked to construct a probability histogram for this probability distribution. So this isn't too hard to do at all. Really all I'm doing here is sketching out a quick picture of what this would look like if I measured probabilities on my vertical axis and I just measured my different possibilities for my X on this horizontal axis. So notice here I could list out like here's 0, 1, 2, and 3, and I'm going to just go ahead and create some bars with associated matching heights with the probabilities. So let's suppose that 40% is all the way up here, since that's my highest. I'm just going to try to eyeball a lot of this, so like here's 20%. So I know that would be 10, and like this would be 30. So if I was going to go ahead and create some bars here, on 0, I need to go up to a height of like 13%. So let's see, that would be like 10, go a little bit higher, maybe there's 13. Remember, since this is a histogram, my bars should actually touch, and so I'm going to kind of create bars that straddle my different numbers along the axis here. See, 1 is at 17%, so that's going to be just a little bit higher. 2 goes all the way up to 40%, so we'll just create something that kind of looks like this. And 3 goes to 30%, which would be somewhere around here. So there we go. I can start to see then a little bit of how this is even shaped, right? Maybe I could say that, maybe this is slightly skewed off to the left, and I can kind of understand where the probabilities get stacked up higher and lower very quickly in this visual representation. Now, once I have this nice table, I can see that I've been following very clearly the steps on this associated formula sheet. You can see that we started off by identifying the random variable. Then we went ahead and we saw that it actually was a discrete variable, specifically a generic discrete distribution is what we worked with. And then we went ahead and we ended up making a table. which essentially allowed us to check that all of our conditions for this distribution were met. We had to make sure that all of our probabilities added up to a grand total of 1 or 100%, and that all probabilities ended up somewhere between 0 and 100, or 0 and 1. Okay? So we could then go ahead and move down to the next step here, which is to state parameters of our distribution, which are our mean and our standard deviation. However, I'll add here on our formula sheet that we really only ever look for these values when we are asked to do this. So if I have a problem that says find the mean and the standard deviation, then I would go through this step. Otherwise, I can kind of circumvent or move around this particular step. And we'll see in a later video exactly how we find these specific values. And finally, after doing all of those things, I get to actually potentially trying to use calculator commands to compute different probabilities. So there's a lot of stuff that I have to do before I get to probability calculations. Although what we see here is that there are no fancy calculator commands, and instead we're just going to use that probability distribution table that we constructed to compute these probabilities. Now let's go ahead and see how we would do that by taking a look at something like Part C. All right, now really quickly, for the sake of argument here, or sorry, just for the sake of clarity, I'm going to go ahead and just compute or set up my table down here so it's easier to see and I don't have to constantly be scrolling back up. So I think these were the different values that I had. I think I'm writing them down in a slightly different order, but it's the same idea. So this was the table that we were working with. Well, what happens now if someone goes ahead and asks me the question, can you find the probability that X, remember, stands for the number of episodes watched by Kyle, is less than 1? Well, all I would have to do here is to think about, okay, wait a minute. If this says, find me the chances that Kyle watches less than 1 episode, how many episodes does that mean that I watched? If I watched underneath 1 episode, then isn't that the same thing as asking, find the probability that the number of episodes watched by Kyle is equal to 0? Like I watched no episodes? And of course, I can just stare at the table and see that, boom, that's already 13%. Question over. Notice I can do the exact same thing when I take a look over here. Find the probability that the number of episodes watched by Kyle is greater than or equal to 2. Well, notice that means I could have watched 2 episodes or 3 episodes. So this is like the probability that the number of episodes that Kyle watches is 2, or the number of episodes that I watch is 3. And so, of course, I'm just taking those 2 percentages and adding them together. It's really just this easy. Boom, 70%. I can do the same thing even down here on Part E, where things get to looking a little bit intimidating. Notice I have a vertical bar here indicating that I'm working with a conditional probability. Now hopefully you remember that conditional probability formula, but if you don't, then you can go ahead and look it up really quickly. What you can see here is that I can kind of imagine treating this first inequality here like an A, and this next inequality here like a B. And so remember that the formula for computing a conditional probability said that I wanted the probability of A and B at the same time, and then I would divide by the probability of B. So you can see how I've written that out there. Notice I haven't grabbed any numbers yet from this table. Now I have to think about each side of this fraction and see if I can come up with an answer. Now, the bottom here is really easy, so let's start with that one. What's the probability that X, the number of episodes watched by Kyle, is greater than or equal to 1? Well, can't I just immediately see it's going to be these numbers from the table? The 17, the 40, and the 30? In fact, I'm just going to go ahead down here and just show that those are exactly the numbers that I'm going to be adding up. And I think as a grand total, that comes out to be 0.87. Okay, so the bottom's not bad, but what about this numerator? How do I find x's that are less than 2 and are also greater than or equal to 1? Well, notice you can almost just go through and do an experiment one number at a time. Like, let's start with the number 0. Is 0 less than 2? Yes, yes it is. Okay. Is it also greater than or equal to 1? No, no it's not. So I can see here that this is definitely a bad number. Not going to work here. It doesn't meet both criteria. What about the number 1? Is that less than 2? Yeah. Is it also greater than or equal to 1? Yes, yes. Okay, so that works. What about 2? Is 2 less than 2? Nope. So if it's not less than 2, it doesn't matter if it's greater than or equal to 1. It didn't meet both criteria. It fails. What about 3? Is 3 less than 2? Nope. So then it can't meet both criteria. What's the only number that meets both criteria at the same time? Well, it's the number 1. So really up top here, I just am going to be left with the probability that x is equal to 1. Or I could just go ahead and just rewrite this in as the exact probability of that 0.17. So I have 0.17 out of 0.87. And if I was to go to a calculator and round this off, I think I end up with the decimal value of 0.1954. So calculating probabilities here really shouldn't be that complicated. It just is going to require that I look over the table and think carefully about what I'm being asked to find. Notice I never wrote any of these percentages inside of any of my parentheses. That never happens. I have to think about what x values meet the criteria and then go grab their associated probabilities. Once I have that, I can work my way down to a final answer. In the next video, we'll take a look at how we can actually find the mean and the standard deviation for one of these generic discrete distributions when we are asked to do so.